question says you are given that 177,147 is equal to 3 to the power of 11. Right, 177,147 with another 6 zeros over here as a product of its prime factors. So again, when you have a product of prime factors, you could only multiply prime numbers together to give you the number that they want. We have to use this piece of information that says to me that 177,147 is 3 to the power of 11. So that's already given to us. That has to be part of my answer. And if I compare over here, that means that this part over here is 3 to the power of 11. And what I'm left with is I have to multiply the whole of that number by 1 million, which is 10 to the power of 6. Now, if I have to compare these two now, 10 is not actually a prime number, so I can't use 10. What I can do instead is I could break that 10 down into 2 times by 5, which are two prime numbers multiplied to give me 10. Because if I have to do that, I know that 2 times 5 gives me 10. So when I have a bracket, I have a power inside the bracket. When you don't have a number, just write the number 1 over there. I have a power inside the bracket and a power outside the bracket. If I use these rules of indices, a to the power of n to the power of m is equal to a to the power n times by m, then I have to multiply the powers together. So this becomes 2 to the power of 6 times by 5 to the power of 6. And now this is actually in the form of a product of prime factors. I like to write the numbers down in order. So 2 to the power of 6 times 3 to the power of 11 times 5 to the power of 6. And that is my answer.